Welcome to Chapter 10. We're going to be talking about probability. We're going to first of all talk about what is probability. We're going to understand the rules of probability. We're going to look at probability models, discrete and continuous. And we're going to talk about random variables. Now in Chapters 1 and 2, we learned about descriptive statistics, describing and summarizing data as it is. And in Chapter 3, we looked at modeling, and now we're going to look at probability. So probability in modeling data deals with data as it's predicted to be. Now the methods that we use to generalize from a sample to a population are based on probability and probability models. That is, inferential statistic techniques. So probability is the science of chance behavior. Chance behavior is not predictable in the short run, but has a regular and predictable pattern in the long run. We study outcomes or results of experiments, and each time we conduct an experiment, we may get a different result. Probability models the long-term behavior of the experiment. So probability is going to relate uncertain short-term results to long-term predictability. Now, a short-term result could be something like you flip a coin 4 times and you see how many times you see heads or tails. The long-term result, we know, a fair coin would yield heads about half of the time. So if we flip that coin, 1,000 times, we would expect about 500 times to see heads, 500 times to see tails. But in the short term, we could flip a coin and see 4 heads. That could happen. Random. What is random? Well, individual outcomes are uncertain, but there is a regular distribution of the outcomes in a large number of repetitions. Relative frequency, it's the proportion of occurrences of an outcome settled down to one value over the long run. That one value is what we define to be probability of that particular outcome. The idea of probability is empirical. What does that mean? Well, it's based on observations rather than theorizing. Probability describes what happens in many, many, many trials. So we say the long-term proportion of heads after a great many flips is a half. This is called the law of large numbers. As the number of repetitions of an experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of that outcome. So let's do some definitions. First of all, we're going to talk about what's an experiment. Well, it's a repeatable process where the results are uncertain when we're dealing with probability. What's an outcome? Well, it's one specific possible result. And the set of all these possible outcomes is called the sample space. So let's look at this example. If we roll a fair die and it's 6-sided, that can be our experiment. One of the outcomes of this is to roll a 4. The sample space, all the possible outcomes, is 1, 2, 3, 4, 5, or 6. And we denote the sample space by the letter S. An event is a collection of possible outcomes. We'll use a capital letter to describe events. So, for example, the capital letter E. Outcomes are also sometimes called simple events. We'll use lowercase letters such as little e for outcomes or simple events. So one of the events, E, for rolling this die, could have been to roll an even number. And E consists of these outcomes, rolling a 2, a 4, a 6. Those would be the different outcomes of that particular event, rolling a die, an even number on the die. So let's look at some important rules of probability. The probability of any event has to satisfy that the value of that probability is a number between 0 and 1, including 0 and 1. As our probability gets close to 0, that means the event is unlikely to occur. As a probability gets closer and closer to the number 1, like 0.99 or 0.90, something like that, that means the probability of that event occurring is pretty high. It's likely to occur. Let's look at rule number 2. If S is the sample space, then the probability of the sample space happening is 1. So something's got to happen. Now, if we take two events, A and B, and they're disjoint, that means that they have no outcomes in common, then if we were to know the probability of A happening or B happening, that would just be the addition of both of their probabilities together. And the last rule is the probability that A does not occur equals 1 minus the probability that it does occur. Now, another way to look at this is the probability. Let's look at a big circle, and here's all the outcomes that could happen. The big circle. And this little piece of it is A. Everything that's not A is over here, not A. So if I add those two up together, what am I going to get? I'm going to get 1. So the probability of A plus the probability of A not occurring has to equal 1. And so there's where that formula comes from. You just do a little algebraic manipulation, and there you have it. Now here a closer looks at the rules, but basically when we say that a probability is between 0 and 1, including 0 and 1, now remember probabilities are no more than proportions. I told you that in Chapter 3. So you can't have more than what you started with. So think of a pie. If you cut the pie into pieces and you looked at 1/3 of the pie and then you put that third back, you can't have more than one pie. You know, you can only add things up to create a whole. It's the same thing with probabilities. And you can't say a probability can be a negative number because there's no such thing as like a negative piece of pie. If you eat it, it's gone, but it's not like a negative piece. Now, because an outcome has to occur for every trial, the probability of all possible outcomes has to equal 1, and that's rule number. Here's an example of two disjoint sets. So if we looked at being under 21 being 25% of the people, 20 to 24, 33%, and greater than 25, we would have to say is it's 42%. Because when we add up all those percentages, it has to equal 1, which leads us basically back into that the probability of the event not happening equals 1 minus the probability that the event does happen. And if you read this example, you can see that. But my illustration earlier, I think, also shows this particular rule quite well. Now, as I said earlier, if we get 0 as a probability, that means the event is impossible. I just said as we got close to 0, it makes the probability of that event happening unlikely. If we said the probability of an event happening is 0, it's impossible. If we say that the probability equals 1, that means the event is going to happen. And we're going to make as our rule of thumb here that an unusual event is one whose probabilities are 5% or less. They're considered very low probabilities, and we would say that it is an unusual event. So how do we